Our tutorial, Sharpe Ratio Performance Metric. Portfolio performance metrics consist of portfolio expected or realized risk premium by unit of risk. This topic is part of advanced portfolio analysis with our course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please read full tutorial disclaimer at the end of this video. Sharpe ratio consists of portfolio expected or realized risk premium by unit of risk. For full reference, I recommend that you read William Sharpe, The Sharpe Ratio, published in the Journal of Portfolio Management in 1994. As a formula, first we have the ex ante Sharpe ratio, in which the expected portfolio return Sharpe ratio is equal to, and within the numerator we have the expected risk premium as the difference between portfolio returns minus the risk-free rate of return, which is then divided by the expected risk premium standard deviation. Here, standard deviation with the Greek letter sigma. And then we have the ex post Sharpe ratio, or realized Sharpe ratio of portfolio returns, which is equal to, and within the numerator we have the portfolio returns mean minus the risk-free rate of return mean, which is then divided by the risk premium standard deviation. For these formulas, we can also use, instead of the risk-free rate of return, we can use a benchmark rate of return. If the risk-free rate of return is not constant through time, and here we'll be using the example of the ex post or realized Sharpe ratio, we have that the portfolio return Sharpe ratio is equal to, and within the numerator we have the portfolio returns mean minus the risk-free rate of return mean, which is then divided by the risk premium standard deviation. Again, risk premium as a difference between portfolio returns minus the risk-free rate of return. If the risk-free rate of return is constant through time, then the portfolio return Sharpe ratio is equal to, and within the numerator we have the portfolio returns mean minus that constant risk-free rate of return, which is then divided by the portfolio returns standard deviation. And if for simplicity purposes we assume a 0% risk-free rate, then the portfolio return Sharpe ratio is equal to, and within the numerator we have the portfolio returns mean, which is then divided by the portfolio return standard deviation. Great. So let's go into RStudio so that we can study Sharpe ratio with greater detail. Excellent. So here we are within RStudio. In this tutorial, we'll be working within our tutorial Sharpe ratio performance metric code file. So the first step within the tutorial is to load its packages. This is done with the library function and within it the package name. In this case, we'll be using performance analytics with capital P, capital A. So we select that code line and then we click run or Ctrl Enter on the keyboard, which is equivalent. The following step is to create the data for Sharpe ratio performance metric calculation. For this, we create this object, which is named returns, and it's equal to read.csv, and within it we have the data file, Sharpe ratio performance metric data, as a plain text file with .csv or comma separated values and stored within the working directory, comma header equals to true. So again, we select the code line, then we click run or Ctrl Enter on the keyboard. Notice that this created a returns object within the global environment as a data frame. So if we click on the spreadsheet kind of icon, we see the corresponding data. We have two columns of data. First of these dates, as we can see, dates with a monthly frequency from the beginning of 2007 all the way to the end of 2016, therefore 10 years of data. And then we have SPY. This corresponds to SPY, adjusted close prices, monthly arithmetic returns because of this monthly frequency. SPY corresponds to the ETF investment vehicle, which intends to replicate the Standard & Poor's 500 index, and adjusted close prices because they were adjusted for dividends and splits. So back into the code file, the next step is we're going to convert that data frame into an XTS. XTS stands for Extensible Time Series. So we override returns object as an XTS as mentioned previously with that function, and we're going to select from returns that second column with those corresponding returns, comma, ordered by equals as date with capital D returns the first column where we have those dates. And we're going to rename the column names of those returns with SPY. So we select those two rows, and then we click Run or Ctrl Enter on the keyboard. Excellent. So notice that now we have the returns object as an XTS or extensible time series, and if we reopen the data, we see that now the dates became its index. So back into the code file, now that we have the data ready, we can proceed with the Sharpe ratio performance metric calculation. So first we're going to do it with this built-in function, which is Sharpe ratio, capital S, capital R, of the previously created returns object. Notice that we're assuming a 0% risk-free rate. This is done for simplicity purposes. It's an example for educational purposes, therefore not fixed, and it can be modified according to your needs. And the function for the calculation with FUN is going to be STD-DEV or standard deviation. So we select that code line there, click Run or Ctrl Enter on the keyboard, and notice here that it printed that corresponding Sharpe ratio. So as we have the data with a monthly frequency, so we had those monthly arithmetic returns, therefore this will be a monthly Sharpe ratio, and again assuming a 0% risk-free rate for simplicity purposes as an example for educational purposes, which is not fixed and it can be modified according to your needs, and the corresponding results of that monthly Sharpe ratio. So then we're also going to calculate it using mean function of returns divided by SD, which is the standard deviation of those returns. So we select this code line here, and then we click Run or Ctrl Enter on the keyboard. So notice here that we have an equivalent calculation to the one we had above for that corresponding monthly Sharpe ratio, assuming that 0% risk-free rate, done for simplicity purposes as an example. Therefore, this educational example is not fixed and it can be modified according to your needs. Excellent. So now that we finished studying Sharpe ratio performance metric calculation, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't consider any type of trading or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this, we finished this tutorial. Thank you for watching.